Alright, so for this problem, again, I see that the denominators are not the same, and we know the drill by now that same denominator, find the multiples. So I can find my multiples of 3 and 9. Multiples is just a fancy word for skip counting, so you don't have to feel like it's something you don't understand. 3, 6, 9, 12. So same denominator, find the multiples. What kind of multiples? Least common multiple. Least is the smallest, so the smallest multiple that they have in common. Well, when I look at the multiples, the smallest one that they both have is a 9. They're smaller, but they're not common. So the smallest one in common is a 9, and that tells me the least common denominator is a 9, which means the new denominator is a 9. Another case of the good news, bad news. Good news, this is fine. Bad news, this needs fixed. No worries. 2 and 2/3 needs to have a denominator of a 9. How do you get from thirds to ninths? How do you get from 3 to 9? You multiply by 3. 3, 6, 9. Do the same thing to the top, same gift, and you get 6. But don't forget, this was 2 and a little bit more, 2 and 2/3. So this needs to be 2 and a little bit more. 2 and 6/9 is the equivalent fraction. So we're not using 2 and 2/3 anymore. I'm going to cross that out and say instead we're taking 4 and 1/9 minus 2 and 6/9. Okay? So now I can subtract the numerator, denominator stays the same. Sweet. Let's focus back on my problem. Subtract the numerator. 4 minus 6, numerator 1 minus 6. Uh-oh. 4 and 1/9 take away 2 and 6/9. This is the bigger number, right? 4 and a little bit more. Take away the smaller number, 2 and a little bit more. So I know there's more up here, but when I am focusing on these numerators, 1 take away 6, I'm having a lot of trouble and I can't do it. I can't do 1 take away 6. If you have 1 M&M, can you give 6 to your friends? No, you don't have 6 to give, you only have 1. So this is where the magic trick comes in. You do have more up here. You don't have enough in the numerator, but think about where do you have some that you could use? In the whole number. What if I take 1 away from this whole 4? And instead of calling it a 4, I call it a 3. Well, why on earth would I do that? Put that 1 over here real quick while we talk about it. So far I've taken 1 away. I need to do 1 subtract 6, and I can't do it. If I take 1 away from the whole number, it's sitting up there right now, can I call it something different? Instead of calling it a whole, I need to make more ninths. I only have 1/9, but I wish I had more. What if I make this 1 whole into 9/9? Is 1 whole the same thing as 9/9? It is. So what if I take this whole and now, like magic, I dump it into the numerator? So I had 1/9, and now I'm adding 9/9. Add the numerator, denominator stays the same, and now I have 3 whole and 10/9. I know it's improper, but now if you go back to subtraction, I can say 10 minus 6 is 4, denominator stays the same, and 3 take away 2 is 1. 1 and 4/9 is my answer.